Okay, question 11. Show the derivative of tan is 1 on cos squared x. The solution there is here. This is tan. You've got to know that tan is sine on cos, and so you do the quotient rule and you'll get eventually this coming out here. Also using this identity that sine squared plus cos squared is 1, because in the unit circle cos is the x coordinate and sine is the y coordinate. So if you've got cos there and sine there, and this is the unit circle, then 1 squared equals cos squared plus sine squared. So it all reduces down to this. Next question was consider this function. It's got the tan function in it, which we've got, which we know the derivative is 1 on cos squared, and it's asking us to show algebraically there's only one stationary point. So we have to stationary points when the derivative is 0, so we have to do the derivative of this function and make it equal to 0. Okay, so doing the derivative, here's the function. There. Doing the derivative, derivative of sine is cosine, derivative of tan is 1 on cos squared from part A, and derivative of 1 is 0. Now the stationary point is when that derivative is 0, so we make this whole thing equal to 0. Take that on the other side and it becomes minus. Then we could multiply both sides by cos squared and we get cos cubed. And now we cube root both sides. If you cube root minus 1, it will still be minus 1. And so we're solving when cos is minus 1. Now on the unit circle, the cosine is negative 1 when you have an angle of pi radians, because here the coordinate is minus 1 comma 0. This is the cosine value at minus 1. Now this is the only solution, because we're going up to 2 pi, which is a full rotation. The next time you get it occurring is 2 pi plus pi, so it's actually 3 pi. But we're stopping at 2 pi, so there's only that one answer. So now we can work out what the coordinates are by putting pi into the function, and we get 1. So the coordinate is pi comma 1. And that pi 1 is a stationary point. Now it could be a maximum, a minimum, or a stationary inflection. And part 2 is going to determine what type that is by getting the second derivative. So if you look at the second question, it's got here that find the second derivative at that same point pi, and then state the significance. So if this turns out to be 0, then it means it's an inflection, so it's a stationary inflection. If that's not equal to 0, then it's a maximum or minimum. And we find that it actually does turn out to be 0, because here's the second derivative, and you get that, and then when you put in pi you get 0. So therefore the stationary point is a point of inflection. So you're looking at something like this. That's called a stationary inflection, and we can see it down in this graph here. There it is occurring there. This is sketch the graph and then state the period. Now the period, it says here 2 pi, but I disagree with that, because it looks like the time for it to repeat, you could take it from here to here. That's the time for it to repeat, which is actually pi. This is pi on 2, that's 3 pi on 2, the difference between that is pi. Okay, so now back to 14. This is a rate of volume. This time they give you the derivative, not the volume. So state the period. Now the period is 2 pi divided by b, the b being the bit in front of the x, in this case it's t. See that really is pi on 8 times t, so that's our b value, pi on 8. So it's 2 pi divided by pi on 8. Now you've got to invert multiply, so that's 2 pi times 8 on pi. They cancel, so you're getting a period of 16. And the meaning of that means that the rate repeats itself every 16 hours. State the initial rate, find the minimum, find the maximum, all during the 16-hour period, and state when it occurs. So that's all solutions are in here. So we have here that the initial rates when time 0. Put 0 in for t and you get 2.5. The minimum is going to occur when the original function was 2 plus 0.5 cos of pi on 8t. So the minimum is going to be, let's just check that formula, that was plus 0.5, that's right. So the minimum is going to be when this thing here is -1, because all cosine and sines range between -1 and +1. So the minimum is going to be when it's -1, the maximum is going to be when it's +1. So when it's -1, we're going to have 2 minus 0.5, and when it's +1, we'll have 2 plus 0.5, this one here. So that's the maximum, that's the minimum, and so here's the minimum here, here's the maximum here. To find out the time when that occurs, well, that's when we made that -1, that's when it's a minimum. When it's a maximum, we find when it's +1. Now to solve that equation for t, that means pi t on 8 has to equal pi plus a multiple of 2 pi, because that's the cosine. Now the cosine is -1 when we're back here, when the angle is pi. So it's when that angle is pi, and we can keep going around 360, so keep adding on 2k pi. But we've got to lock it at 16. That's when we cut it off. So the times by 8, divide by pi, and so you get 8 hours. And that's, if you do the next bit, it's outside the range. Down here, it's when it's equal to +1. Now it's +1 when it's over here. That's when it's 0, the angle 0. So here's the angle, make it equal to 0. If you rearrange that, that's t equals 0. But if you add on another k2 pi, you can get another one which is 16 hours. Because if you take this one here, it's really, if we times by 8 and divide by pi, it's t equals, now 0 plus k2 pi is k2 2k pi. If we times by 8, right, and divide by pi, the pi's go and you end up with 16k. So when k is 0, you get 0, that's that first one. When k is 1, you get 16, the second one. Okay, and next one is, how can you tell the water is always entering the reservoir? So if you have a positive slope, then the function's always increasing. Because this is always positive, because cos ranges between -1 and +1, that means this whole thing will always be positive. So since it's positive, that means V is always increasing, so the volume is always getting more and more and more. It's just that the rate is changing in a cyclical manner. So C, we have, since the derivative is positive, then the water is always increasing, entering it. Next one is to find the expression for the volume of water. The volume, we have to integrate that, and it's in the first 10 hours. So it's just simply the integral 0 to 10 of the derivative. And then part E and F is basically doing that for specific times, and you can go through that in your own time to do those, because that's a little bit too specific, I'd say, for this test. Next one is 5. how many revolutions, you just count them up. So we got 1, 2, 3. And then it can be modelled by A take B cos nt, and we have to identify A, B and N. Okay, so we've got here the period. It is the function that they gave us was A take B cos nt. A take B cos nt, that's the function. Okay, so the period is 2 pi on B, and the B is the n, so it's 2 pi on n. And the period we know is 3, because there's one period from a trough to a trough. So we can rearrange that and we got the value for n. If you want to find the A and the B values, well, the maximum is when this whole thing is going to be -1, because then it'll be A plus B. But when that's +1, it'll be A take B. So when the cos is -1, we got the maximum A plus B, and we know it's 50, and the minimum A take B is 2. So solving those two simultaneous equations, we can get A and B, and therefore we got the total function sitting there. Right, question C. How long does it take the chair to travel from the highest point down to a point 20 meters above the ground? The highest point is halfway between 0 and 3, 1.5. This one here, and we want to go down to 20, down to that level. So from there down to there, we want to get this here. Now to go down to 20, that'll be 2.37. You could get that from the graph. You could punch this into the graphics calculator and put t equals put in y equals 20 and intersect it, or you could make this 20 and solve algebraically for time, and you get this value. So you take the difference between them, that's the time it takes to travel from 50 up the top down to 20. It's the difference between those two times. Now 6, we've got this function here, and we want to get the derivative and the integral. That's pretty straightforward. Part B, we're given the derivative function, a different derivative function, and we want to find A, B and C. Okay, so we'll do that one. You can see A is straightforward, where we've got just the derivative done there and the integral done there. Part B, to work out the A, B, C value, the way they got those values is, this is pi on 3. We can't assume that this distance here is pi on 3 because they've got that little cut squiggle. We do know this is pi. In terms of pi on 3, we could call that 3 pi on 3. So if this is 1 pi on 3, and that's 3 pi on 3, that means this must be 2 pi on 3. So this distance here is the difference between 2 pi on 3 and pi on 3, which is pi on 3. And so that means a small one between there and there is half of that, which is pi on 6. So each step is pi on 6. Okay, so to get A, we're going to add on pi on 6 to pi on 3. If you do that, that's the same as 2 pi on 6 plus pi on 6, which is 3 pi on 6. Cancel that down, that's pi on 2. So A is pi on 2, that's that one. 2 pi on 3 is sitting there already, so that's that one done. And you can do the same technique to work out C, just add on pi on 6 to 2 pi on 3 and you'll get the C value. Clearly the period is 2 pi on 3 because that is this distance from here over to there. So it's a pi on 3 and another pi on 3, 2 pi on 3. It asks for area. We don't need to go into that in this section, but you just do the integral from the start to the finish of that function. Okay.